Hello, Mr. Hine. Hope you guys are doing all right. We'll try to keep this quick, but this is meant to help you understand slope, which we've been talking online as a rate of change in the context of a race, because that's a very common way of understanding how things change is through the idea of like speed. So understanding slope is a rate of change. So let's say there is a race. All right? And in this race, there is, let's say that I'm in the race, so Mr. Hine is in the race, and we'll say Mr. Dean, which is a teacher might have when you're in the race. Okay. Now, if I graphed my equation, so if graphed, my equation looks like f of x is equal to 3/4 x plus 1. And Dean's race, and this will make sense, I'm going to explain this, is represented by 5/11 x plus plus 3. And we'll say that this race is 10 meters long. So what's all this mean here? So if I'm going to make a big graph here, and we'll try to make sense of this. And on this graph, there's 0, 0, which is the start. All right. And let me make sure you can see my paper. Okay, good. And we'll call this time in seconds. And this will be your distance, which we'll have in meters. Now, if we were to graph my equation, let's see what this means. So that plus 1, remember that that's your starting value. So at 1, I put a point. And then my slope is 3/4, means I'm going right 3 over 4. Up 1, 2, 3 over 1, 2, 3, 4. And I'll mark that with one slope triangle here to help you see that. And we can keep going up 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3 over 1, 2, 3, 4. And then you can connect that. And there's my equation. That's Hine. Okay. And if I did Dean's in red, I'll highlight Dean's in red. He starts at 3. So from 0, 1, 2, 3. So he's starting at 3. And he's going up 5, right 11. So up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And since his is so far, I'm just going to try and do my best to connect those like that. And that's Dean's equation there. Now, what's all this mean? So in a race, if that's the starting point of the race, notice that I started 1 away. So what's that mean? That means that I had a 1 meter head start. Right? I didn't start at the starting point. I started 1 meter ahead, so I had a head start. And notice my distance, I'm moving away from the start. So what this is saying here is I was going 3 meters, because notice I was going up 3, so 3 meters. And how long did it take me to go up 3? Well, it took me 4 seconds. So I was going 3 meters every 4 seconds. Right. Similarly, if we look at Dean's, what's his happening in the race here? Well, his 3 means that I got a 1 meter head start. He actually had a 3 meter head start. And he was going 5 meters because he was going up 5. So he was going 5 meters for every 11 seconds. And you can see how now in the context of a race, that slope represents a speed, right? I'm going 3 meters every 4 seconds. Dean was going 5 meters every 11 seconds. That's how fast you're going. Like if I was driving, often here in the States, we'd say, 70 miles per hour. It's a distance per time. Right? Now, part of this lesson too is you understand that, but if I ask you who's faster, right? Well, there's different ways you can see it. From a graph, you could just say which line is steeper, which one is steeper. In which case, who's steeper here is, it looks like my line is steeper, so you would say Hein. But how do you do it with numbers, with algebra? Right. Well, now I was going, remember, 3 meters every 4 seconds. And Dean was going 5 meters every 11 seconds. And that's kind of hard to see who's faster, but what we can do, and this is a big thing of this lesson, is you can get what's called a unit rate, which means per 1 second. Now, how do you get the unit rate? Well, if it's 3 minutes for 4 seconds, I want to know how fast am I going per 1 second? Just do 3 divided by 4. So if you did 3 divided by 4, and you use a calculator for that, 3 divided by 4, what we get is 0.75. So I was going 0.75 meters per 1 second. Or you could just write 0.75 meters per second. I mean, they're both saying the same thing. And then for Dean's, if we did 5 divided by 11, he's going, we'll just use the first term as 0.45 meters per second. So 0.45 meters. I need to move my calculator so I can write this per 1 second, which is, about 0.45. We are like this. So clearly you can see who's faster. Well, I'm faster because 0.75 is larger than 0.45. Right? But that's the idea of a unit rate, is you want to find per 1 second where you do division, right? And that will work out. And I think that's all you need for this lesson. Let me see. So we talked about the head start. Their slope represents their speed. Right. Maybe you can do one more example to make sure you get this. I'm looking at the problems right now that you have to do. Okay. So let's look at 2 more examples. Okay. So let's say, for example, there's a third racer. And we'll call this racer Mrs. Velarde, another teacher in the math department here. All right. And all we know from her is we have some information in a table. So we'll say time and distance. And we know that we were just keeping track every 5 seconds. She was at 8, and then she was at 11, and then she was at 14. And if it asked her what was her speed, what would we figure out? Well, notice that she's going from 8 to 11. That's plus 3 meters. So it's 3 meters per, how long did it take her? Well, it took her 5 seconds from the 5th to the 10th second. So then you would say 3 meters per 5 seconds. And if you wanted that as a unit rate, which again means per 1 second, do 3 divided by 5. So break that down, and what you would get if you use a calculator is 0.6 meters per 1 second. Or you can just write that as 0.6 meters per second. And that was her speed. And that's good too. So you can see how sometimes from a table we can get that speed as well. I hope that's enough. There might be a question there that I didn't go over here, but that's also because I want you to, be challenged a little bit. Math is about the challenge and figuring things out, and not always about just being a robot and being told what to do, because that's not how the world is anymore. So hope this helps you get started, make some sense of it, and then hopefully from there, read the questions, figure out what it's asking, and just do your best, because that's all we can ask of you. Good luck.